National Center for Cryo-EM Access and Training Glacios tutorial. Welcome to our National Center for Cryo-EM Access and Training, also known as NCCAT. Today we will learn about the Glacios operations. I'd like to introduce you to Allison. She is our Glacios Cryo-TEM created by Thermo Scientific. This is a 200 kilovolt FEG screening microscope with an autoloader. This is our microscope PC with hand panels. Over here is our loading interface, and behind this window is where we can load our nanocabs. In our control room, we have our microscope PC, our support PC, our Legend PC, and hand panels. On our left hand panel, the most important function that we will use is multifunction X. On our right hand panel, we will use diffraction, multifunction Y, stage movement, and R1 for screen lift. On the microscope PC, we see the vacuum panel. Make sure column valves closed is yellow, which means true, and that the values are green. We want to make sure that the scope was left in SA mag. In apertures, take out the objective. If it's yellow, we want that to be gray. Temperature control should be set to all nitrogen temperatures. And in the autoloader, we can see empty slots in gray. The grid currently on stage is yellow. The other grids in the cassette are blue. On the microscope PC, go to Desktop and load NCCAT Legend on Client. On the Legend on PC, go to Terminal and type NCCAT Legend on. Create a new session. Next. Search for your project. Next. Here, let's choose Glacios-X1 as the holder and click Next. In the description, we can put Glacios- and you can name it whatever you'd like. Next, the image directory. Make sure that it says BEEGFS/legendon/your LDAP account. Next, connect to clients. Add client Glacios 9953149. Select OK, then Next. Our C2 aperture is going to be 70 microns. We can double check that in the apertures on the microscope PC. Select Finish. Go to Application. Select Run. Application is Glacios MSIT Nano. Main is Glacios Legendon. And scope is Glacios 9953149. Run. Go to Presets Manager node. At the bottom it says Import from previous sessions. Our TEM is Glacios. Our digital camera will be the Falcon 3. Find the last sessions from the past 20 days. Select. Go through the presets to make sure that they are satisfactory for your session. Once complete, you can select all with Ctrl-Shift-A and then import and select Done. Send the grid preset to Scope. Go into Navigation, and you can obtain the image from there, or you can click R1 to insert screen, or use this button up here. Open column valves. Now let's go to the Search tab, and let's send our location for carbon. Click Go. Due to multiple loadings and unloadings, the orientation of the cross-grading grid may shift, so let's find a fully intact carbon square using stage movement. And now let's update that location. On the Legend on PC, let's go to the Z Focus node and simulate a target. Let's double check our settings. Make sure that the preset order says whole and manual focus preset is FCN. In the focus sequence settings, let's make sure rough is set to square and fine is set to HLN whole, and manual after is FCN. We can use peak and correlation to make sure that we see a peak in the corner of the image, and this is to ensure that we are indeed finding eucentric Z focus, or eucentric height. Now let's click Manual Focus. Let's send 0 to scope. And let's toggle Show Resolution Defocus. Click on the first 0 or the first darkish ring that we see, and let's go up an increment. If the rings contract, then let's go down an increment until we can see that the first ring blends out to the edge. And that will be our true 0. Like there. All right, let's reset this defocus. Click Stop, and we're done. Now let's go to Presets Manager and send Tune to Scope. Put the screen down. And let's go into Direct Alignments and select Beam Tilt Pivot Point X. Using the multifunction X knob, we're going to try to minimize the movement that we see. We're going to repeat this for pivot point Y, using multifunction X again. And for rotation center, multifunction X again. And click Done. Then we're going to do beam shift. We're going to try to center the beam using multifunction X and Y knobs. When satisfied, let's click Done. Let's go to our Apertures tab. Let's go into diffraction mode. And let's insert our objective aperture. We want to use 100 microns. If off center, let's adjust by clicking the Adjust button and using multifunction X and Y to center the objective aperture. Unclick Adjust when done. Now let's come out of diffraction mode. Back on the Legend on PC, let's go to Beam Tilt Image. Let's make sure settings are correct. Preset order needs to be FCN. Okay, now let's simulate a target. Set view to tab blue. Zoom out to 1/4 mag. We want the left and right and top and bottom FFTs to be identical. Use the crosshairs to view your center. If the images are not the same, use the cursor tool to click on the center FFT in the direction of the better image to fix the dissimilar image. Once fixed, let's go to the Search tab, click Vacuum, and go. Let's send grid to scope. And if we're not over vacuum, let's use stage movement to go over vacuum and update this location. In navigation, let's send square mag to scope, acquire. Using crosshairs, let's see where we're located. We are over vacuum, so let's go up in mag. Let's go to ENN, acquire. This is to confirm that we are indeed over vacuum. Now let's go to the correction node. In settings, we want our TEM to be Glacios, our digital camera to be the Falcon 3. Our dimensions will be 4K by 4K, bin by 1. Our exposure time will be 1000 milliseconds. Our exposure time per frame will be 40 milliseconds. Click OK. Back on the microscope PC, we'll go to Autoloader tab and we'll close column valves. On Legend back in corrections, we'll go to dark, both channels, and acquire. Once complete, we'll set it to bright and acquire. Column valves will automatically open. Now let's do corrected, both channels, acquire. And this is our corrected image. Go to navigation, let's send ENN to scope and acquire. Write down or memorize the mean value. Let's go to ICE T node. In settings, we want our ice thickness using aperture limited scattering to calculate ice thickness from aperture limited scattering. Our ALS coefficient is 1055 and our vacuum intensity for exposures images is that mean value. In Presets Manager, we're going to go to ENN preset and acquire dose for this preset. We want our value to be between 30 and 65, which it is. Select yes. Let's make sure image shift and beam shift is 0, 0 for ENN, FCN, and FAN. Now let's do preset alignments. Let's send grid to scope. On the microscope PC, let's go to the search tab and let's go back to carbon. Using the navigation tab, let's acquire an image at grid. Let's find an object of interest and let's go to that location using the cursor tool. Let's go up in magnification. Let's send whole, acquire, we found our object of interest. Now let's put the beam over it using the cursor tool. Let's go up in mag, let's go to ENN and acquire. And let's find a particular spot on the object that we want to be over. I'm going to go to the tip of this odd looking thing and we're going to go down in magnification to whole and use image shift to acquire image. Now I see that we're not there, so let's use our cursor tool to actually go to the same location that we were in ENN. In Presets Manager, let's go to the whole preset, settings, and import that image shift that we just changed. Save. Back in navigation, let's go down in mag to square, acquire image shift, and repeat the process. Let's go back to that same point. In Presets Manager, let's go to Square Settings and import that image shift from the instrument. Save. Back to navigation. Let's go to Grid, acquire image shift, and this part is a little bit tough, so just try to be over the object. Presets Manager, Settings, import that image shift, and save. And we're done with preset alignments. In Square Node, let's simulate a target. Let's go to Whole Targeting Node Settings. Make sure that Allow for User Verification is selected targets and Queue Up Targets is checked. In Whole Settings, we want to make sure the preset order is HLN. In Exposure Targeting Settings, we want to make sure Allow for User Verification is selected. Okay. Exposure, we want our preset order to say ENN. In Focus Node Settings, we want our preset order to say FAN, our manual focus to be FCN, our melt preset to be FCN. In Focus Sequence Settings, defocus 1, the preset should be FAN, defocus 2, FAN, and manual focus after is FCN. Okay. In Whole Targeting Node, if there's already an acquisition and focus target, we can remove it by right-clicking on it and replacing it where we need. Now let's submit targets and also submit the queue. Now let's go to Z Focus, make sure that we're at eccentric height. In Whole, we'll see our image. In Exposure Targeting, if there are already targets, we can remove them by selecting Acquisition Targets, Control-Shift-Right-Click, and place the targets that we actually would like. Don't forget a focus target, and submit. Let's go to Focus Node. Let's make sure that we're at eccentric focus by playing with peak and correlation. Make sure the peak is in the corner. In Exposure Node, these will be our exposure images. Let's go to NCCAT web.nysbc.org and two-way viewer. We want to set the first view at whole, and the second view will be ENNs. Make sure the targets are aligned. Click Processing, select Frame Alignment, go to Motion Core 2, just show command. Let's copy this command. Let's go into our command line, open 4 new tabs. We're going to SSH space ingest -04. If this doesn't work, SSH space 192.168.4.67, paste your command, enter. Let's make sure it runs. Great. Open text editor, paste the command. Let's change the GPUIDs to 1. Copy the SSH command and paste it in each tab. Copy our new frame alignment command and paste it in the second tab. Now let's go back to our image viewer. Let's refresh and make sure that we see ENN-A and dose weighted images. Go to processing, estimate the CTF find 4. Our ENN-A is preset and just show command. Let's copy this command. Open terminal, paste your command. Add space, -- NPROC equals 5. Go into the other tab and paste and repeat. And now CTFs will be generated for each ENN aligned image. On the microscope PC, let's close column valves. Take out our objective aperture. And let's load our first user's grid. Open column valves. Let's go back into Legion. Using navigation, we can send grid and stage position, acquire. Let's use our cursor tool to center over a square. Let's go to Z focus node, simulate a target. Once complete, go to grid targeting, settings. Let's change the name for our label. We can make this grid 1 or whatever you'd like. We can change the radius to whatever we'd like. The maximum that we can do is 0.009. Smaller atlases will take shorter time. Okay. Calculate the atlas. And publish the atlas. If we go to the grid node, we'll see our grid images taken here. And if we go to square targeting, we'll see all the grid images being stitched together into complete atlas. On the microscope computer, insert the objective. Go back to Legion. Place acquisition targets on squares of differing ice thicknesses. Submit Q. Go to hole targeting. Let's remove the target that's already there. Let's go to template settings. Using the ruler tool, let's measure the diameter of a hole. Let's input that value into the template diameter. Click test. That's not great, so let's go up an increment. All right, that looks good. We have bright white peaks in the center. Okay, let's go to threshold settings. Let's test. Yeah, that looks good. We have blobs. Let's go to blob settings. And let's test. Let's increase our max blobs. Test. We can change our minimum blob size and our maximum blob size based off of the sizes that we want. Let's go to lattice settings. Test. You can use the ruler tool to measure lattice to lattice, and you can change this number in spacing. Let's go to acquisition settings. If you hover over a lattice point, you can see the mean intensity, mean thickness, standard deviation intensity, and standard deviation thickness. Let's delete our acquisition target. Let's measure from our lattice point to the center of 4 holes. Let's input the D value here and the A value here, and we only want 1 target. Now we're getting 4 holes for each acquisition target. Submit target, and let's repeat this for each square that we picked in square targeting. Now submit the Q. Let's go to exposure targeting, template settings, Let's measure the diameter of the hole. Let's change our value in template diameter. We want that bright white peak in the center, so let's that diameter. Keep testing. Let's do threshold settings. Set it to 2. Blob settings. Test. We're missing the top right blob, so let's increase our max blob size. There we go. Now let's go to lattice settings. Test. If you want to accept all blobs, set spacing to 0. Acquisition settings. Now let's hover over the lattice point. We can change our settings based off of that number. Let's use the ruler tool and go from acquisition point to center of the 4 holes. Delete the focus target template, autofill, and insert those values. Okay, test targeting, perfect. We want our focus in the center. Now if you wanted to change your acquisition targets and put them at different locations of the hole, you can measure that out and change your acquisition targets. There you go. Okay. Press play. After focus is complete, you'll see all of your exposures coming in. Let's go back to NCCAT Web, Image Viewer, refresh, and you'll see all of your ENN images. You'll be able to see your ALS ice thickness, your magnification, your defocus, your pixel size, your dose for each image. And this is the name of your image. Go back to Leginon, go to Presets Manager, go to ENN, Settings, and you can change your defocus here, or you can create a random defocus range. Once your cue is set, you can toggle error notification, and this will close column valves when the scope is inactive for 30 minutes. In exposure targeting settings, we can take off allow for user verification. Exposure node, when acquisition process data is done, you can then end your session. Leave the scope in SA Mag, close column valves, take out the objective aperture, load the cross grading, back on the Leginon PC, go to Application, Kill, File, Exit, close Firefox, close all tabs, close your terminal, close text editor, and log out. Thank you for watching.